Okay, we're picking up here with, I believe this is lecture video 4 for chapter 2, and lecture video 3 left off with this question number 17. So to refresh you where we are in those lecture worksheets. So before we go on with any more numbered things, I want to go over what's called dimensional analysis. Okay, essentially we're going to be doing unit conversions. So in the previous videos, we talked about that metric conversion table, where we talked about how grams relate to kilograms or milli relates to something else. And so just to use an example of kilograms to grams, we have the relationship in that table that says 1 kilogram equals 10 to the 3 grams, right? And so I can also say 10 to the 3 grams is the same thing as 1,000 grams, right? Now I can take this equality and make a ratio, right? And so we're going to be using a lot of ratios, but you don't necessarily have to worry about the concept of ratios. But when we have this one thing equals another, I can write it as a fraction. I can say 1 kilogram over 10 to the 3 grams, or because it's equal, I can say 10 to the 3 grams over 1 kilogram. Okay, either one works because they're equal to each other. I can write it either way. Now what we're going to call these, we're going to call these conversion factors. All right, that's what the basic term for those are. And we're going to use those to go from one unit to another unit. So our strategy for doing unit conversions, okay, is first we start with the given information, given info. And again, I have to apologize for my handwriting. Hopefully you can decipher what I'm writing here. Most of the time it's not too bad. We're going to start with the given information, and then we're going to use a conversion factor that has the unit we want to get rid of on the bottom. Right, so the easiest way to sort of put this into context is to work a problem. So let's try a problem. We want to convert 965 grams to kilograms. Okay? So we have these conversion factors up here that relate grams and kilograms. So I'm going to start by writing my given information, 965 grams. And then I'm going to pick a conversion factor that has grams on the bottom. And that's this one right here, the first one. So I'm going to write that as a fraction. So I'm going to say 1 kilogram equals 10 to the 3 grams. Right? Now what happens when we deal with fractions is that things will cancel each other out. So 965 grams is the same thing as writing it as 965 grams over 1. Okay, so I have a fraction there. And when I have grams on top multiplied by grams on bottom, those grams will cancel out. Okay, the units will cancel each other out because we're dividing one by the other. So what I'm going to enter into my calculator, I'm going to say 965 divided by 10 to the 3. Or to put it in terms of what you see in your calculator, divided by E3. Okay, if it's on the bottom of the conversion factor like it is here, we divide. If it's on the top of the conversion factor, we multiply. In this case, we're multiplying by 1, so we don't have to worry about it. And so our answer here will be 0.965 kilograms, because kilograms is the unit that's left over. Okay, so since I'm a little bit running out of room here, I'm going to erase this part so that I can do another example. So in our next example, let's convert 6.2 feet to inches. Now this is probably something you've done at some point in your life, and you've probably busted out a ruler or maybe busted out your calculator, but we're going to put it in context of doing a unit conversion. Okay, so our relationship is 1 foot equals 12 inches. And so because of it's equal, I can write it as a ratio. So I can write it as 1 foot over 12 inches, or, and that's important, or I can write it as 12 inches over 1 foot, however I need it to be. So to solve the problem, I'm going to start by writing my given information, 6.2 feet, and then I'm going to use a conversion factor that has feet on the bottom. That is this one. Okay, so 12 inches over 1 foot. My feet will cancel because I have feet on top on the left and feet on the bottom in my conversion factor. So feet will cancel out, leaving me with an answer in inches, which is what I want. So I'm going to say 6.2 times 12, because 12 is on top in this scenario. And we'll end up with an answer that is 74.4 inches. Now, if I'm employing my significant figures rules correctly, this really should be reported to the right sig figs as just 74 inches. Because I only have 2 significant figures here, and my conversion factor, because it's a definition, has infinite sig figs. All right, so I'm limited to 2 significant digits. Okay, so that's how we do these unit conversions. So now we're going to jump in with question 18 and start employing the same tactics. Okay, so in this scenario, I have 1 calorie equals 4.184 joules. And that's a definition. So that relationship is going to have infinite significant digits. So I can write that either way. I can say 1 calorie over 4.184 joules, or 4.184 joules over 1 calorie. And in case you're wondering, because I'm sure a lot of you are interested in dietary things and medical things, this calorie, this lowercase c calorie, is not a dietary calorie. So if you're not aware, your dietary calories, like what you see on a nutrition label, are actually kilocalories. So one of these regular calories, so it takes 1,000 of them to make 1 dietary calorie. Okay, and joules are a unit of energy. So if you want to find out how many units of energy there are in your food, you have to multiply by 1,000, which is a lot of units of energy of food. So if you're ever looking for a motivation for dieting, calculate the energy in joules of your food, and we're going to do that right now. So our strategy for doing unit conversions, start with the given information. So 1314 joules. Now I'm going to pick a conversion factor that has joules on the bottom. and that's this first one right here. Okay, so I'm going to say 1 calorie over 4.184 joules, right? Because joules on top divided by joules on the bottom, that makes my joules cancel out and leaves me with an answer in calories, which is the unit that I want. So that equals 314.05 calories. And since I only have 4 significant digits here, and this one is a definition, my final answer should have 4 significant digits. So I'm going to look right here, and I'm going to look 1 digit to the right. That's a 5, so I'm going to round up. So to the correct sig figs, this one will be 314.1 calories. So continuing on to number 19. So convert 43.9 micrometers to meters. And remembering this funny looking U shape is the symbol for micro. Okay, so our relationship is 1 micrometer is 10 to the minus 6 meters. So I can write those relationships as fractions. So 1 micrometer, 10 to the minus 6 meters, or 10 to the minus 6 meters over 1 micrometer. Both of those things are true because they're equal to each other. I'm going to start with my given information, 43.9 micrometers, and I'm going to pick the conversion factor that has micrometers on the bottom, and that would be this one right here. So 10 to the minus 6 meters over 1 micrometer. My micrometers will cancel out, leaving me with an answer in meters, which is what I want. So in my calculator, I'm going to say 43.9 times e to the minus 6. Remember to use that EE button, that second EE button, okay? And we should get an answer to the correct number of significant digits of 4.39 times 10 to the minus 5 meters. All right, number 20. So cubic centimeters to liters. Right, so here's our relationship. I can write that as fractions. So 1 liter over 1,000 cubic centimeters, or 1,000 cubic centimeters over 1 liter. While you're getting used to this process, it helps to write these relationships out, both of them, so that it's easy to see which one you want to pick. So I'm going to start with my given information, 593.3 cubic centimeters, and I'm going to pick the conversion factor that has cubic centimeters on the bottom, this one right here. Okay, I put it on the bottom so that my units will cancel out, leaving me with the answer in liters, which is what I'm after. So I should get an answer of 0.5933 liters. Now, if you have your calculator set in scientific notation, this would also come out to be 5.933 times 10 to the minus 1 liters. Okay, both of those things mean the same thing. All right, so then here's our answers. 18 was 314.1 calories. 19 was 4.39 times 10 to the minus 5 meters. And 20, 0.5933 liters. So we were correct, at least according to the slides. All right, 21 is a bit of a challenge question. So a 2016 Lamborghini Aventador has a top speed of 217 miles per hour. Boy, would I like to drive that car. what is the speed in meters per second? Okay, so we need some conversion factors going on here. And in this case, we're going to use more than one. So one conversion factor is miles to meters. So we'll have 1 mile equals 1609.34 meters. And then we need 1 hour is 60 minutes. And 1 minute equals 60 seconds. Okay, so remember, we can write all of these as fractions. So I can write 1 mile over 1609.34 meters, or 1609.34 meters over 1 mile. 1 hour over 60 minutes, or 60 minutes over 1 hour. 1 minute over 60 seconds, or 60 seconds over 1 minute. All right, so we're going to be using all three of these in this problem. So it's a bit of a jump. We went from one-step conversions all of a sudden to a three-step conversion. Now I'm going to show it in one continuous equation, but I want to make it clear that you can do this as one step at a time if it makes you more comfortable, if you understand it better, okay? So we're going to start with the given information. So 217 miles per hour. Okay, notice that miles are on top of the hours. Okay, so I'm going to start with, I can start by converting time if I want to, or I can start by converting miles. I'm going to start with the miles because that's a one-step thing. I can go straight from miles to meters. So I'm going to pick a conversion factor that has miles on the bottom. So that has that one written all over it. So I can say 1609.34 meters over 1 mile. All right. Let me switching back with colors just to make this clear. So the miles will cancel out. Now, I could calculate that number and then do the next step. Okay, so that's what I mean by doing this one step at a time. I could take this answer and then do a separate equation if I want to. But I don't have to. That's the beauty of this conversion process. So if I did stop here, I would have an answer that is meters per hour. But I'm asked to find meters per second. Okay, so my next step is I'm going to use a new conversion factor. And because the hours are already on the bottom, I need to pick a conversion factor that has hours on top in order to make it cancel out. So that's going to be this one right here. So I'm going to say 1 hour is 60 minutes. Okay, as long as they're on opposite sides of the fraction from each other, they will cancel out. So I've got hours on the bottom, will cancel with hours on top. So if I stopped here, I would have an answer that is meters per minute. So I'm going to do one more step to get me all the way to meters per second. So right now, I've got minutes on the bottom, right here. So I need to pick my next conversion factor to have minutes on the top so that they're opposite and they cancel out. So that's going to be this one right here. So 1 minute is 60 seconds. So my minutes on opposite sides of the fraction will cancel out. So now my units that are left over, all right, take a look through all this business and see that the units that are left over, I have meters on top and seconds on the bottom. So I want meters per second. So I'm done. And what's nice about this process is you can look through and check your work. Make sure that you have the answer that you want. So in my calculator, what I'm going to enter, anything that's on top, I multiply. Anything that's on bottom, I divide. So I'm going to say 217 times 1609.34 divided by 60, because it's on the bottom, divided by 60, because it's on the bottom. And I should end up with an answer that is 97.0 meters per second. All right, and originally this slide had information in here, but as we have transferred things from one format to another, some of that stuff has been lost. But our final answer is correct, meters per second. All right, I'm going to go ahead and stop this video right here because I think we're probably close to the 20-minute mark, and we'll come back with question 22.